Okay, it's Jillian here. Let's check out what's going on with finite differences. Oops, there we go. So we've looked at differences before. We know that the difference between, well, let's take a look at it from here. We know that when x is 0, y is 5. When x is 1, that's 2, plus 5 is 7. When x is 2, 2 times 2 is 4, plus 5 is 9, and 11, and 13. Now, the difference between these two is 2. The difference between these two is 2. 2 and 2. In fact, when you have a line, which you know this is a line because you know y equals mx plus b is a line, if you didn't, you could find the differences between the y values, and if they are all the same, then you know when the first differences are the same that you have a line. When the first differences are not the same, and you are going to then take the differences of the first differences, we call that the second differences. And when the second differences are the same, we know that then we have a quadratic or a parabola. So basically, when the first differences are the same, you have an equation with y equals x to the power of 1. And when the second differences are the same, you have an equation with x squared in it. And when the third differences are the same, you'll have an equation with y equals x cubed in it, which we're not going to take much notice of in this course, but I just wanted you to make that connection, that when these are the same, that's the equation. So you know y equals mx plus b and y equals mx plus b, so these are all lines, and therefore their first differences will be the same. Let's see what happens here. Here we see that we have parabolas. Parabola all over the place. We've got these 3 parabolas. Now, we know that if we find the second differences, they're going to be the same. So let's just do one to show that it works. When x is 0, 0 squared plus 0 plus 1 is 1. When x is 1, we have 1 plus 1 plus 1, which is 3. When x is 2, we have 2 squared is 4, and 4 plus 2 is 6 plus 1 is 7. When x is 3, we have 3 squared is 9, plus 3 more is 12, plus 1 more is 13. And when x is 4, we have 4 squared is 16, plus another 4 is 20, plus 1 is 21. So let's look at these differences. The difference between 1 and 3 is 2. The difference between 3 and 4 is 4. The difference between, 3 and 7 is 4. 7 and 13 is 6. And 13 and 21 is 8. So those differences are not the same. However, the difference from these two is 2. The difference between these two is 2, and the difference between these two is 2. So when you do all of these, you will find that when the second difference is the same, you have an x to the 2 in your equation. Now let's see what happens here. What happens if they give us the differences? And we just need to find out if the question is linear, quadratic, or neither. So here, this difference is 1, 1, 1, 1. So we don't need to continue. We know that it's linear because the first differences are the same. Here, we're going up by 2, 2, 2, 2. It's linear. Here, we're going up by 1, 3, 5, 7, so those aren't the same. However, that's going up by 2, that's going up by 2, that's going up by 2, so it's a quadratic. And I think you get the idea. Okay, so take a look at these. If you like, you can pause the video so you see the questions and give them a try.